recording. This is objective 8.1b. We've already done C. We're coming back to B because this was a short lesson and a Monday was a good day to do it. Okay, topic for today is coterminal, complementary, supplementary angles and radians. And our essential question is more of a task. Define coterminal, complementary, and supplementary angles, but do it in terms of radians instead of degrees. So let's start with just the definitions of those three terms, and then we'll put them into practice. So we'll start with coterminal angles. And if you'll recall, coterminal angles are angles in standard position. With different measures. Oh, that's not an R. Measures, I don't know what that is. Measures, but same terminal side. So basically what you're doing here is we're just working in radians instead of in degrees. So like for example, if I give you angle theta and I want you to find an angle that's coterminal to that, I'll ask you to add 2 pi, because that's 1 full revolution in radians, times some number of revolutions, we'll call that n. Okay, and over here let's just define n. Pi is an integer. N is an integer. Okay, so a set of numbers, -2, -1, 0, 1, 2, ... It's an integer, which would be positive full revolutions or negative full revolutions, -1, -2, -3, like that. So it just represents basically how many revolutions are you going to make, but they have to be full revolutions. Okay, so that's coterminal. Let's talk about complementary. And so if you recall, complementary angles have a sum of 90 degrees. They are acute angles. So we're going to say acute angles whose sum is, instead of 90 degrees, we've got to talk in terms of radians. That would be pi over 2. So acute angles whose sum is pi over 2. So for example, angle alpha plus angle beta is pi over 2. Okay? And then lastly, defining supplementary angles. And if you don't mind, I'm just going to go ahead and abbreviate that. And I'm sure that you can tell me the definition of supplementary angles now that I've reminded you the definition of complementary angles. Now, supplementary angles, you don't have to have only acute. In fact, only acute angles wouldn't work. 89 degrees plus 89 degrees is not 180 degrees, right? But it's just 2 angles. Let's do 2 positive angles. 2 positive angles whose sum is pi, right? Radians. Right? Supplementary adds up to 180 or adds up to pi. So, for example, alpha plus beta is pi. So these are like concepts we already know. Nothing new. We're just talking in radians instead of degrees. Okay? So let's look at this example here. Example 5 says find a positive angle and a negative angle that are coterminal, same terminal side, with 2 pi over 3. Of course, many answers are possible, because you can do multiple revolutions. You can pick any integer you like, but let's keep it simple. Okay? So 2 pi over 3, let's draw that. If I were to put that, oops, I didn't want to move that, on the coordinate plane, in standard position, there's 0, there's pi, 2 pi, pi over 2, 3 pi pi over 2. So there's our quadrantal measures for in radians. Okay? Where would 2 pi over 3 be? Quadrant 1, 2, 3, or 4. Think of it as 2/3 of pi. Where would that be? Quadrant 2, right? We just take pi and we cut it in thirds, right? So we come here and here. So this would be 2 pi over 3 radians. Okay, so what you're looking for here now is a negative coterminal. Oh, let's go with positive first. A positive coterminal with 2 pi over 3 and a negative coterminal with 2 pi over 3. So if we go positive, I'll grab my green pen to indicate that I'm going in a positive direction. I want to go positive coterminal. What would I have to do to 2 pi over 3? To get back to the same coterminal place, but have a different measure. Add 2 pi. And we'll go one time. Yeah, we'll do one revolution. So let's start at 2 pi over 3. And let's go positively plus 2 pi. That'll take us right back to the same position, but now we've added 2 pi radians to that measure. So really what we're looking at is this measure from here to here. One full revolution and then 2 pi over 3. So how do you propose we do that? I think we could just, add them. So maybe I'd tuck a 1 under that and I'd make them have common denominators. So times 3 times 3. So we get 2 pi plus 6 pi all over 3, if they both have the same denominator, right? Which would be 8 pi. And that would be considered one positive full revolution from 2 pi over 3. Pretty basic concept. Okay, let's go in a negative direction. So for 2 pi over 3, and we want to go negatively, we would start here and rotate back 2 pi over 3, correct? True? Yes. So we're starting at 2 pi over 3, and we're adding 2 pi times 1 negative revolution. Remember that the n is just the type of revolution, and it's an integer. So I could really just say minus 2 pi, right? Totally could just say that. But I'm going to go ahead and do times 3, so we have common denominators. So that would give us 2 pi minus 6 pi over 3. I think you could probably, if you look at these compared, you can just see, you just change the sign in your top value or your top fraction. This opposite sign in your bottom fraction, then you would get your negative value, negative 4 pi. And that would be a negative. Questions? Ask them if you have them. We're good? Oh my goodness. All right, then. All right, so now we're going to find the complement and the supplement of pi over 6. So complementary angles create a right angle. So here we are at 0 radians. Here we are up here at pi over 2. We're working in radians. With pi over 6, well, I'm going to extend this out to pi. It just says we're going to take pi and we're going to cut it into 6 slices. Right? Yes? Pi divided by 6, that's what that says? Mm-hmm. So we would cut that in 30-degree slices, but of course we're going to talk about it in radians instead. So this would be pi over 6 and 2 pi over 6. And of course we can continue to work all the way to pi. And here's pi over 6. What we're looking for is what's its complement. And I want to know what is that measure. So we take pi over 2, subtract pi over 6. Does that make sense? Subtract the two values and it'll give me the complementary value. So common denominators again. So I think we can go with 6. So that'd be 3 pi minus pi all over 6, which would be 2 pi over 6, which we then could reduce down to pi over 3. And so that would be our complementary value. So that's the complement. Let's go to the supplement. Supplementary angles we know add up to pi. We've already got the picture up here. So now what I'm looking for is this measure. And you could probably count it out and see it right now if you're counting in pi over 6. So we would take pi, radians, subtract pi over 6. So we'll put that over 1, give them common denominators. So 6 pi over 6 minus 5 pi over 6. So we'll do 6 pi minus pi over 6, which is 5 pi over 6. And that would be your supplement. Now, the nice thing about your little calculators is these little guys, you plug them in, they'll do all of the common denominator business. It's not like I need to test you on can you find common denominators. You're in pre-calculus, I know you can do that. So let's not get stuck on the math. Let's make sure we're focused on the concept. Do you understand? Yes. Right? If this is pi over 6, then this is 2 pi, 3 pi. That is left over 1, 2, 3, 4, 5 pi over 6 to get to pi. Right? All right. So there you go. That's it. That's it. That's what we have for today. So remember on the assignment, it was the 8.1 AB assignment, problems 3 and 6, 9 through 20 all, and then 22 through 58, every other